guys, keep solving our physics subject GRE. So 11, a beam of neutral atom in their ground states is moving into the plane and on this page and pass through the region of strong homogeneous magnetic field. So I ask you about what's the beam path. So basically this is the same simple question because you have an electron and then you know that there is a inhomogeneous spin, a homogeneous magnetic field. So remember the Stenger-Log. So remember the Stenger-Log experiments. The electron has spin SZ component is plus or minus half. So you have to separate into two. So the answer is split vertically into two spin. Okay, and the 12. 12 I already said many times. But you should remember the Bohr model. This 13.6 depend basically actually it's proportional to the effective mass. So from the hydrogen you have a proton and the electron. So the effective of mass of this me over mp divided by ne plus mp, which is this. But actually the mp is large, so it's close to me. But now you have the thing called positron. Basically they have the same mass as me, so the effective mass is me over 2. So the positronian have this effective this answer. Okay, so 6.8 divided minus 6.8 divided by n squared. So the ground state is answer is C, minus 6.8. I suggest that you remember the property of positronian because it's really famous. Okay, so 13 said there's 100 watts and the heating element is placed on 1 liter water. Although heating elements for long time water close to boiling does not boil. When heating element remove approximately how low will take the water could cool by 1 degree. Okay, so basically we have 1 kilogram volume, 1 kilogram water, and the power is 100. So basically the heat is just mc delta T. So basically we have equal to the power times time. So basically 100 times T equals to this should be used 1000 times 1 times the temperature. Which we get. Oh, remember the C is the sorry, I forgot. So this C is 4.2 because we need to change it to joule. So we have T equals to 4200 minus 100, which is close to 42. Sorry, this is not 1, this is 4.2. Because I need to change kg into kilo, 4 kilojoules. So the answer is close to B. Okay, and so for 14 said that you have 2 identical blocks of copper, and the one is 0, one is 100, and you match it together. So you know that the final temperature just their average because they are the same material. So the final just 50. And what you ask about is that the amount of heat. So from 0 Celsius to 50 Celsius, what we have is just the mc delta T, right? So what is m? M is 1. And C is 0.1 kilojoule, 0.1. And that is 50, so 5k cal. So the answer is A. The answer is A. No, the answer is okay. So unit is kilocalorie. Calorie. Okay, so number 15 basically asks you about you have some thermodynamic process, and one molecule asks about the net heat. So this type of problem is difficult because you need to calculate case by case. So we start from the process. We start from the process A to B. So this is isothermal. So we know that isothermal, we have the work basically is P. So remember that we have one more. So PV equals to RT. So this is one is RT over VdV from V1 to V2. So we have work, which is this one. And the heat is basically the energy, the internal energy plus the work. And the internal energy is CV delta T. And in one molecule ideal gas, which is CV delta T. So, but this is isothermal. So the U is 0. So this is the AB. We have W and U is 0. So this is U. And the W is, and so heat is the same as W. Okay, then the second process, which is, let me see. How about we choose BC? Oh, maybe, yeah, BC. BC is difficult, right? Because we have work just the constant, so B2 times V1 minus V2 basically is R times Tc minus Th. And then the energy is, the internal energy is just the temperature difference. Basically it's CVTh minus Tc. So Q is just W plus U, which is CV. So W basically you have CV, so this is minus R Th minus Tc. So you have CV minus R. Let me see. So minus R. Oh shit. Sorry. So this is plus. So Q have CV minus plus R, Tc minus Th, which is just Cp. Tc minus Th. And this is isobaric. Okay. So the third part is C to A. Basically C to A, there's no difference of the volume, so W is 0. And then the U is just CVTh minus Tc. So the Q is just CVTh minus Tc. And all we need is sum of over all these Q. So we have this one plus this one, and the original this one. And then we can get an answer is E. Because you will have Cp minus Cv, so you will have some R remaining. So the answer is E. And the 16x could tell you that the mean free path. And this is the number of density, the collision, and ask about what's the mean free path. So basically, this is physics intuition, because you say the mean free path should at least large. So 10 to the negative 10 is already the atomic level, so which is too small. So the answer should be A or B. And actually, there's no easy way, but the answer should be A. This is just actually I don't have a other method to get this one, but you can guess that it should not be too small as B. So 17, this is a wave function, and it asks you about the probability found to be 2 to 4. So basically, just ask you about the probability integral from 2 to 4. So basically, all you need to do is we first do the normalization. So we have 1 squared plus 1 squared plus 2 squared plus 3 squared plus 1 squared. So this is 16. Okay, and the fraction from 2 to 4 basically is 2 to 4 basically is 2 squared plus 3 squared. So the fraction of this divided by this is 13 over 16. So the answer is E. Okay, and give you a potential and ask you about what is the correct shape of the ground state. What's the correct shape of a wave function possible? Okay, so remember that when your total energy is larger than 0, then you should be sine cosine. So let me summarize. When your total energy is larger than 0, then the answer should be sine x or cosine x. Some k. Okay. And then when total energy is less than 0, basically in this region, you have some exponential decay. So the first one, this should be sine cosine. And this one, the middle should be exponential decay. So the only remaining C. And the D and E are not possible, because for E, the middle one should be exponential decay. For D, these two should be sine or cosine, basically oscillation. So the only remaining is C. C has what the feature what we want. Okay, so 19 said where alpha particles are directed into one atom and make a very close collision of the nuclei of the atom are scattered large. If the alpha particle with initial is 5 mega, MeV happens to be scattered to an angle 180, and the virtual volume must be the distance closest. Okay. So this is just as about the Coulomb interaction. So when you are this is alpha, this is the nuclei, which are very close to each other. So the closest point basically can be solved by the Coulomb interaction. So this is your Coulomb interactions. This is your potential term. And what we have is, this is 50. This is 2. So we have 100k times R divided by R2 squared. And the Q is just 1.6 times 10 to the negative 19. And what is this? So so basically this will be the kinetic energy and 5 MeV. So we can use this to solve our R. Okay. So we have this. This is K. This is K. And then we have this square divided by R is equals to 5 times 10 to the 6, 1.6 times negative 19. Okay, so we can solve this R, and so R is close to this is I approximate this 10 to the 10, so we have 10 to the 12, and 10 to the negative 7 times this one, and also divided by 5 times 10 to the 6. So close to 10 to the negative 14. So which one? So the answer is B. The answer is B. 10 to the negative 14. So 20, a helium atom makes the 4U. So U is like the atomic units. Okay, travel with the non-relative speed normal to the surface of certain material makes the elastic collision of the surface atom and leaves the opposite. Okay, so basically this is all. This is a question what we have done. The same elastic collision. So you have V elastic with an essentially free surface atom. So what I can assume that this surface atom is rest. So this is M. Okay, so the original VC is NV divided by M plus M, and the rest, so final is minus 0.6 equals to 2mv M plus M minus V. We have 2m. So we have small m minus large m, small m plus large m, V. This is 0.6 V. Okay, so we can solve this. So what we have is this 3/5. So we have large mass is 4 times mass. So that means the large n has 16 units. So which one has 16 units? The answer is D. 16U. Oxygen mass. Oxygen. So the answer is D. The answer is D. Okay, congratulations. We have solving 10 questions, and we will keep solving the rest. And be sure to subscribe to my channel, and I will see you guys in the next video.